Good morning, everyone. It is a few minutes after 11:30 Eastern, so we are going to go ahead and get started. My name is Nicole Deringer from Boundary Systems. Thank you for joining us for our weekly webinar presentation. This will actually be our last one until after the new year, so be sure to check our calendar online to see what's coming up. Today we are joined by our partners at ITI Transcendata. Steve Myers, who is a senior technical consultant there, is here to present on CADIQ. And with that, I'm going to turn it right over to Steve to get going.
Thank you, Nicole, and good morning, everyone. I'm Steve Myers, as Nicole already said. I'll get to my personal details in just a moment, but I want to be sure that everyone understands that if you have a question, there is a chat window in the webinar interface where you can submit your questions at any time during the presentation, and I'll keep an eye on that so that I can address your questions as they come up. So feel free to use that. Also, for more information after the webinar, you can see some contact information here, both ITI and Boundary Systems listed there with appropriate contact information. So feel free to reach out to us afterwards. Either one of those contacts will get you in touch with the right person to answer further questions or get into any more detail that you might want to cover. So today I'm Steve Myers, and I'll be presenting CADIQ, as Nicole already mentioned. I'm a technical consultant with ITI, and you'll note that my address on the business card there says Milford, Ohio. That's actually our company headquarters. I'm located in a home office in the Portland, Oregon area. So I'm on Pacific time. It's a little earlier for me than it is for most of you. We'll get right into today's topic in just a few minutes, but I want to acquaint you just briefly with our company. ITI is a company headquartered in Milford, as I mentioned, in Ohio, and we specialize in product data interoperability problems. And if you want to kind of know what that means, that's really listed in the center graphic that you see here. So our solutions are around conversion from one CAD format to another, integration of PLM systems, communication between those, and validation of CAD data, migration of CAD data. So really what we're going to talk about today is around the validation piece of that, but we do have a wide range of solutions that cover different use cases for our customers. Some of the initiatives, I'll kind of switch over to the left here, some of the initiatives that our solutions address are pretty common out in the industry today. Model-based enterprise is a concept that a lot of companies are moving toward to eliminate or at least reduce the use of drawings, and many of our solutions contribute to that. As I mentioned before, in terms of product lifecycle management, we have a group within our company that specializes in solutions for that piece of the market, whether it be moving from one PLM system to another or doing other PLM integration type activities. We have a group that handles that sort of thing as well. We have some solutions around advanced simulation and digital manufacturing as well. Switching over to the right side, you can see some different locations there. As I mentioned, company headquarters is in Milford, Ohio, but we do have offices that do development of our different products spread throughout the world, as you can see there. We were founded in 1983, and today we have about 120 different employees. So getting right into the topic today, we're going to talk about our solution called CADIQ. And CADIQ is all about CAD Model Validation. And validation can mean a few different things depending on what your initiatives are. But basically, it can be really broken down into these three buckets that you see on the right-hand side of the slide. 3D model-based producibility checking. So here we're checking for the basic quality of the model. We also give you the ability to validate derivatives from your 3D model if you're outputting STEP or JT or any of the other alternative formats, and you want to be sure that the output equals what you got from the CAD system. Then we have tools to help you validate that those two pieces of geometry are actually the same. And then the third one is with respect to engineering changes that are actual changes to the model, revisions that you would make. And those can be sometimes unintentional or otherwise undocumented. And CADIQ helps you discover what those are and therefore make decisions about them. So we'll be talking about these three different areas. But a good question that comes up at the beginning is, why would you want to validate your CAD files? And really, we'll go back to those three buckets to answer that question. First of all, CAD files, as you well know, can have defects in them, and some of those defects are caused by modeling practices, and other ones just little idiosyncrasies of the CAD tool and how it reacts to different types of geometry that you're trying to create. So some of the things that come up there are confusing structure of the model, data that's inconsistent, features that are unrealistic, or maybe some information that's missing. You can see a couple of examples of that off to the right. As I mentioned before, derivative validation can be very important if you're sharing data downstream in a format that is outside of the authoring tool. So if you're using Creo and you have to share files with suppliers or customers that are in an alternate format such as STEP or any of the other formats out there, you want to be sure that the data you're giving those other contributors to your value chain is accurate, and there aren't any differences between what you have in your CAD tool and what appears in the derivative version of that. And then finally, as models go through the process, or as designs go through the process of completion, there are a lot of different changes that happen. Some of those changes might be related to manufacturing, some of them are simply design changes to make the product function better, but whatever the case, the ability to see exactly what those changes are can sometimes be difficult to spot or difficult to communicate. So when those changes are made, oftentimes the changes are documented on the face of a drawing in the form of a note, or perhaps a document that is attached in the PLM system to the CAD model. And that's a good way of capturing changes and documenting them, but some of those changes can still slip through because they're either very slight or they were unintentional. And it's very important to spot those so that you don't have data going downstream that isn't accurate and isn't preserving the design intent that you had in the beginning. So some of the, as you go through the, I'll just kind of build this whole slide out here. As you go through the process of designing models, particularly in a model-based enterprise where you're really relying directly on 3D data rather than having drawings in the picture, your model may go through a number of different, I'll call them reworks. I don't even know if that's a word, but for the purposes of today, it will be. The model may be reworked for analysis purposes, for prototyping, for manufacturing concerns, and we show some rather dramatic examples on this slide, but the fact is that the geometry can change in ways that render it unacceptable or inaccurate and can result in decisions being made that aren't based on the accurate design. A great example of that here. This is actually a real part that was manufactured based on a 3D model. The simulation was approved, so there was a simulation done on this and it passed muster, indicated that the part would function as intended. Manufacturing produced the initial parts from the model. All the parts failed during final testing, causing a significant delay in the schedule and a requirement for retooling. And you can see what happened to the part here. We have a zoomed in view on the right-hand side where it shows some fatigue failure due to some stress concentration that happened on the part as it was placed in its functional environment. So let's take a look at what actually happened to that. And this gives you your first look in today's webinar at CADIQ and how it looks to the user. So what we're seeing here is a picture in CADIQ of a quality check where we're spotting a zero thickness surface, a little sliver, if you will, that can happen pretty easily in CAD tools when you have draft angles and radii and things like that coming together. You can often get little sharp edges. You notice that we have a radius in place there that would take care of that stress concentration, but as the product went through manufacturing and simulation, it got simplified a little bit to the point where that unrealistic feature actually was not accounted for in the simulation, but since manufacturing worked off the original model, we actually got a situation where we have no radius on the actual part that was built, and because of that, we have that stress concentration and a failed part. So a tool like CADIQ can alert you to these kinds of issues with geometry that if you were to inspect this model visually and shade and spin it on the screen, you might not necessarily see these kinds of defects, and therefore you could be faced with a problem like we're seeing here. So just a quick demonstration of the value there. And while we're on the topic of defects, I want to show you just a few of the types of defects that we can pick up with the CADIQ tool. And you can see examples here where you have a blocked hole, a narrow step. Looking down toward the bottom, you can see in the middle there we have a void that's inside the model where we have a hole that used to go through some geometry, but you can see there's a little wall in there that produces or actually splits that hole into two pieces. And that might not be an issue if I was creating some casting tooling or something like that. But if you're doing a 3D print of that model, the center one in the bottom there with the void, the 3D printer is actually going to print that void inside of that model. So that's probably something that you don't want to have. So again, depending on what your use is downstream, these issues can be serious, very serious, or maybe not so serious, but not knowing about them can cause significant problems. In addition to geometry defects, we also spot defects in the PMI, or the product manufacturing information, that can be attached to three-dimensional models, especially in that model-based design environment. So here we're just seeing a number of different defects that we spot. Probably the most obvious one is in the middle at the top, where we have a profile tolerance applied to what we're going to assume to be the entire inside profile there, but you can see that the surfaces that are actually connected to that profile tolerance are not continuous. Inside the red circle there is a green patch of that surface that actually isn't referenced by that tolerance or by that feature control frame. And you might think, well, it's obvious from looking at that feature control frame that that tolerance is meant to be all around. And that's fine as long as you're looking at that as the human interpreter of this information. That's what we call graphic PMI. There are a couple of terms that you may or may not be familiar with. One is graphic, the other is semantic when it comes to PMI. So graphic PMI just means that a human is going to look at that and interpret that information. This defect isn't important in that case, but if we're trying to program a coordinate measuring machine using this information, we then need semantic information. In other words, interpretable by a machine. And the machine interpretation of this is going to miss that surface that should be included in that profile. So just a little bit more detail on one of the examples here. And you can see several other examples where we have either inappropriate datum references or missing information in the feature control frames. These are all the types of defects that can be spotted by CADIQ that aren't necessarily caught by human inspectors when they're just looking over the drawing on a visual inspection. So you can see here opportunities for, we're going to kind of switch gears here and talk about derivatives. We were talking about individual model quality. Now we're going to change gears and talk about derivatives, meaning alternate formats that are produced from the original CAD model. Wherever you see the sort of brown colored ovals here, that's an opportunity for a derivative to be produced, and also an opportunity for errors to be introduced in the data. So as the data comes from a supplier or maybe from a legacy system into the CAD tool, you may have some translation that takes place there. And then downstream of the design tool, transformations may take place for visualization, for manufacturing purposes, or maybe for archiving purposes. And many times those three deliverables are in different formats. So the question becomes, are these models all equivalent? If we consider the model in the middle, the master model, to be the actual master model, we want to ensure that anything downstream from that is going to be equivalent to that master model, so we don't have the kinds of problems that we saw with the example earlier. So what kind of things can we spot in CADIQ? Here's another look at the user interface of CADIQ. And by the way, I will show a short demo at the end so you'll get a feel for what it looks like real time. But here we're seeing the master model on the left and the derivative model on the right. And you can see here a significant difference between those two. And that's one that would likely be picked up on a visual inspection. But how often do you really display your CAD model and your derivative model side by side? That doesn't in reality happen very often. We tend to trust that process, but we can see by this example, and I'm sure you've seen some examples in your day-to-day work where derivatives actually are not equal to the original model. So here we're showing a rich graphical interpretation or visualization of that difference and giving you very clear information about what the difference is. Another example here is with respect to an assembly where we have a component of the assembly, everything's geometry is completely accurate, but the component of the assembly has changed position as a result of the translation to the derivative file format. So here, I'm not sure if we're seeing a step file on the right, but most likely it is. It's covered up by those labels. But here we're seeing that comparison, and we've got a component that has shifted. And the busier the assembly gets with components, the less likely it is that a person doing a visual inspection is going to see all of these potential changes that could happen. Here is one we're looking at a difference in PMI through the translation process. So we see a couple of things happening here. The face associativity is lost. On the left-hand side, we could see we selected the dimension and the faces on the model inside the hole there are highlighted, and we've lost that associativity on the right-hand side. You can also see a change in the font there where we have sort of a block type font on the right, which is different than the font that was in the original model, which may not be as important. But again, if we're talking about that semantic PMI where we're going to use a program to interpret this data, then this loss of associativity becomes very important. We also have here where there's actually some information missing. We had a statistical symbol in the PMI on the left, and that has disappeared along with some size changes and font changes in the PMI itself. So we look at these in terms of parts, assemblies, and PMI, comparing all of those things to make sure that what you get in your derivative file is equivalent to what you had in the CAD file. Some other examples here where we've lost some cross-hatching in a view, the location of a balloon has changed, and in the bottom example, a circular balloon has changed into an octagonal balloon with facets on it there. So all these things can be spotted easily and highlighted with an automated tool like CADIQ, whereas the visual inspection may not catch all of these. And here's some other PMI differences where you can see the left and the rights are different, and I won't belabor the point and go through all those differences, but on looking at these images you can see that there are some differences between the left and the right which may not be immediately apparent on a visual inspection. And just a few more examples here with surface association being lost and different elements being lost in the process of translation. Now the third, so we've talked about model quality, initial model quality, with features that are appropriate for the intended purpose of the model. Then we moved on to verifying or validating derivative formats of the model, and now we're going to shift gears again and talk about that third bucket or that third area where CADIQ provides value, and that is documenting or spotting model revisions. So here, if I build this out, you can see like that graphic I had up before, we have a number of opportunities where changes might be made to the model. Starting over on the left, going from a legacy model to the current model, we may make some changes there. Changes may just be a result of different revisions of the model as it goes through the design cycle. There may be changes associated with manufacturing, and manufacturing may have a couple of different revisions of the model based on their process needs. So each of the red ovals represent an opportunity for change, and therefore also represent an opportunity for changes that either are unintentional or for whatever reason are undocumented simply because they weren't spotted or known about by all the parties involved. So a couple of examples from CADIQ here then where we've got as-is model on the left-hand side and the revised model on the right-hand side. Now, the idea here is that we've changed the thickness of the geometry. You can see the orange highlighted geometry there, and what has happened is the hole depth did not change with the rest of the model. So we're seeing some extra geometry down there at the bottom of the hole. And again, visual inspection, particularly if you have that model shaded, may not be immediately obvious and may be missed entirely, this type of a defect. I guess I won't call it a defect, but this change that actually does sort of result in a defect here based on the fact that that hole should go all the way through. Here we're looking at a composite layup where we have differences between the model, and it's pretty significant here. So these are pretty easily visualized. You see the composite geometry was changed. It was intentional and it was documented, but there were some attributes associated with that. In other words, text parameter type information that's not geometry that is captured with the model that may be very important for automated processes related to manufacturing, and those items were intentional, but they weren't documented. So CADIQ spots those and allows us to then somehow document those and communicate those to downstream users of this data. Here we have, in the absence of a detailed drawing, we don't have a drawing to redline, so we give you the ability with CADIQ to actually produce a PDF. So one of the questions that actually may have come up in your minds as you've watched this is how do I communicate these changes? I find these things in CADIQ, and then how do I communicate that to the rest of my organization, most of which won't have access to the CADIQ tool? And the answer to that is that you can provide this information in the form of a PDF. So here you're seeing an example of that, and I also have a real, I'll say quote unquote, real example of that to show you as well. But all of the items that CADIQ spots can be included in this PDF report, and that gives you something that you can attach to the model and document the changes. And here again is one of those changes that might not be spotted immediately. We have a tolerance change from 30 thousandths to 50 and could potentially be missed by a human inspector. And just as a summary, I won't read all of these, but this gives you an idea of the wide range of items that CADIQ inspects and gives us the opportunity to document with respect to the models and derivatives and revisions that you work with as you go through the design process. Probably most important to cover here is the file interfaces that we support, and you can see those in the lower left-hand portion of the slide, the CAD tools that we support for inspection of models in terms of quality, and then the different interfaces that we support for derivatives are listed there as well. Okay, so I'll take a few minutes now, and I'm going to switch gears here and change up the display a bit and show you what CADIQ looks like to the user. And to go to, so here we've got a model where we're just showing, this is a quality check. So that was the first area that we talked about, showing defects in the model. And just to give you an idea what that's like, well, let me back up here. The user interface is pretty simple here. You've got menus across the top, different icons that in many cases are duplicated in these menus, but different controls for displaying this model. For example, you could display it in wireframe if you want, or turn it on so that it's shaded based on what kind of information you're trying to query from this model that might be useful. We have an overall view up here in the upper. I'm going to expand this bigger. Actually, that went way too big and spread across all three of my screens, so I apologize. I'm going to try to resize this thing. There we go. I'll stretch it out. I hit the maximize button and I have three monitors and it's spread across all three of them. So what we have here is an overall view of the model. So for example, if I zoom up on one of these items that CADIQ found, I see a zoomed up view of the model in the main screen, and this overall context view that we see in the upper corner here on the left tells me where I am in the model. And I can use the mouse wheel to roll back and forth and manipulate this model in different ways. By the way, if you're used to the way a specific CAD tool behaves, like for example, Creo, that's why I've got the control style up here set to Creo, but you can set it to any of these different CAD tools. And then when you're reorienting the model in CADIQ, you're going to have those familiar controls that work the same way as they do in the CAD environment that you're used to. So let's just zoom up here and take a look at what's going on. We have a sharp outside edge that CADIQ spotted. And as you look at this model, as I rotate it around, there might not be anything obviously wrong until you kind of get at this angle here where we can see this reinforcing rib doesn't actually touch the side of the part, and it results in what CADIQ finds as a sharp edge on the model. So again, one of those things that when we're zoomed back like this, everything looks pretty good unless we look closely at it. So that might be missed, and you can imagine what kind of difficulties this would cause in creating tooling or machining this model. Now you might also be asking, how do I tell CADIQ what to change or what to spot, and then can I adjust what CADIQ thinks is important based on what I think is important? The answer to that question is answered in a set of configuration files that you can edit to configure CADIQ to ignore certain things that aren't important in your environment, or among those things that are important, maybe some are more important than others, so you have CADIQ mark those as more severe conditions. We refer to those as hot, warm, and cold, or if you want to use a traffic light analogy, it could be red, yellow, green, green being good, and on down to red being a significant item that needs to be fixed. So within those items that you do want information about, you can set different thresholds for those, so that maybe what is considered a sharp angle in one company's environment may not be a sharp angle in another. So let's say this angle is 30 degrees here, and I set the threshold in CADIQ to say any angle that's 31 degrees or less is a sharp edge. It's going to spot that. But if I set that tolerance to be some different number that's higher than what I have here, then it wouldn't spot this, or lower than this, then I wouldn't spot this as a problem. So the bottom line is you can configure CADIQ based on what's important for you to know about your models. Okay, so another example then, moving on to changes in a model. So here we have, this would be a derivative validation. I'm going to collapse that one window and make this a little bit bigger. So here we're talking about the differences, or we're looking at the differences between a part file and a step file. And I'm not sure how it's coming through in WebEx, but in the top of each one of these windows is the name of the model we're looking at. So we have a .prt here on the right, or on the left, and a step file on the right. And over in the panel, you can see the different items that CADIQ found in terms of geometry changes. If we expand these, we can see what they are. And as I highlight those, I also want to point out that there's a properties panel down here in the bottom right-hand corner that gives you a rich set of information about that change. Some of it may be very important, some of it may not be important depending on your application, but there's a nice set of information there that can be useful. Now, to zero in on changes specifically, you simply double-click that item in the tree, and what we can see here is that we have a surface area change between the step and the part file. And the way that's shown, there are a couple of different ways it's shown. First of all, if you look over at the left-hand panel where we have the CAD model, you can see overlaid in wireframe is the step surface. So we can see the shaded surface is the surface that exists in the CAD model. We've overlaid the surface that resulted in the step file, and you can see there's an area change there. And to get more information, you can either look over here in the diagnostic panel and see what that area change was right here in the list, or if you simply hover over that label of that surface, you can see the percentage of the change there. So we're just about 5.5% difference between the surface area in the CAD model and the surface area in the step model. Now that doesn't necessarily represent a change in position of that surface, but the construction as it happened in the step file is slightly different. We can also see that some surfaces, based on the translation algorithms, I guess you could call them. I don't know how step does all these things internally, and I don't know all the mathematical terminology, but if it is important in your machining applications or other applications, maybe analysis applications, that this surface be of a certain type, we can see here that where it was a toroidal surface in the CAD tool, it became what STEP calls a complex surface. So if the entity types that you get in the STEP file are important to you, this is information that can be useful for making adjustments to your STEP file translation process, or simply being aware that there's a difference between these two formats. Okay, and then the third example, I'll go ahead and collapse this down. Third example is, this is comparing one revision of the model to another revision of the model. And again, I'm not sure how well this shows in WebEx, so I'll point out the fact that we have on the left side wheelmount.prt, and then we have wheelmount.prt.2. That would be the revision. And we're seeing those side by side, of course. And as I mentioned before, this side by side visualization capability is really powerful. Again, I'll pose the question sort of rhetorically: how often do you really look at two models side by side in your CAD tool? You may do it frequently, but I've been around the industry for a long time, and I don't know of too many customers or users who actually do that very often. Usually it's a matter of markups and things like that. So here we're seeing two versions of the CAD model, and over in the panel on the right hand side, we're seeing what the changes were. So we've got three different categories here. We'll focus on a couple of them. First of all, I have a hole diameter change, two different indicators of a hole diameter change. And let's just double click on the one and we'll see where that is. We can see that this large hole in the central portion of the part there has changed diameter by 0.127. And again, looking down in the properties panel, we can see not only that diameter change, but other pieces of information about the position and condition of that cylindrical surface there. By the way, I don't see any questions at this point, but if you're asking in your mind, what does CADIQ know about the features on the model? The answer is that we're analyzing only geometry here. So while we do use the CAD system to generate this geometry and to extract it from the CAD tool, we're only evaluating geometry, and we don't care if this is a hole feature or a round cut or an extrude or a revolve. That's important on the CAD side, but in terms of comparing revisions, only the geometry in terms of size and position is important. So that's what we're focusing on here. Now, just like before, we can see the difference highlighted in the tree, but you can also hover over the label and we'll see that the diameter change is listed right there with that feature. Now let's look at the other one here. It's actually on the other side of the part. I'll zoom out a little bit. That zoomed up pretty far there. Let's kind of go over here to the other side. There we are. So we've got a diameter change of another hole there. I'll get you a better view of that. There we are. So we're looking down in this hole, and again, hovering over that's going to give us the difference. This is a pretty small change, 75 thousandths of an inch, and on a part this large, that's obviously not going to be visually spotted and may actually be documented as the person made the change, but one of those things that could easily be missed. All right, so those are the three examples I have for today, and they're fairly straightforward, somewhat simple ones, but you can imagine in more complex parts how much more difficult it becomes to spot these kinds of changes and the kind of value that CADIQ can add in that situation especially. And I mentioned before the idea of how do we share this information outside of the CADIQ user community, which tends to be fairly small, right? You're probably not going to have every CAD user in your organization evaluating models using CADIQ, but you will want to communicate that information perhaps to a very wide audience. And the way that's handled is when you are looking at the results in CADIQ, you have the ability, a couple of different ways to do it, but I'll just highlight one right now. Right up here, I have a Save as PDF button. Now, I can generate several custom views by zooming and rotating and capturing those views, and then include those views in the PDF report. And that's what I've done for the example that I'm going to show you now. So I've generated a PDF report, and this is a 3D PDF. And we can see here the same two-window arrangement side by side that we had in CADIQ with clear labels that we have the mount part on the left and the mount part .2 on the right. And I have a couple of custom views saved here. One I labeled these when I was in CADIQ generating this, but if I want to see the change for what I've referred to as hole 1, I can highlight that view. The part orients and zooms to the appropriate position, and then down here in the properties area, I can see right here I've got that change where the hole got smaller by 127 thousandths, or about 1/8 of an inch. Then we also have one I actually didn't highlight in CADIQ, but we also have a curved surface length change. Now I am going to jump back over to CADIQ since we have a couple of minutes to explain that one a little bit better. So let's go here to this curved surface length change. And really what we're seeing here is CADIQ sort of showing us not only the fact that this whole diameter change, that was this one right here in the list, or actually this one, this whole diameter change, but as a result of that diameter change, another piece of geometry actually changed on this part as well. And that would be this radius surface. It got larger. So we can see, or it got smaller as the whole diameter got smaller. Whichever way you go, smaller or larger is going to have the requisite impact. But we can see that not only did the whole change, but it's rather obvious, right, to those who use a CAD tool very often, that if you change this whole diameter, the diameter overall of this rounded surface is going to move with the edge of that hole. So just to show you that CADIQ looks at these things from a number of different angles and documents every geometrical change. Some, like this one, may not be so important to point out, but it speaks to the thoroughness with which we do evaluate the models and to the level of detail that you can get to if it's important. So this curve surface length change, actually I captured as a view here in the PDF file so that you see an example of that, and how much that changed as a result of the diameter change of the hole. Also, if you have access to the Acrobat authoring tool, you can customize these PDF templates to have your company logo on them and to have different pieces of information. You might have an ITAR statement or some other sort of proprietary statement you want to include on these so that when you distribute them, they're adequately documented, what kind of protections you need and that sort of thing. So all of that is doable outside of CADIQ by editing the templates that we provide. And then, of course, you'll get that customized information when you generate the report. So at this point, I haven't seen any questions in the, I'm going to check one more time here. No, I don't see any questions in the text. I encourage you that if you do have questions that you type those in the couple of minutes that we have left here. And seeing that there are none, I'll turn the time back to Nicole to finish things up. I want to thank everyone for your attention today, and also remind you, just pop this back up here, how you can contact us. I'm going to just do a little bit of navigating here and then pop that up to the full screen. So I'll leave it off here with our contact information and turn it back to Nicole. And thanks again, everyone, for your attention today.
At this time, we'd like to open it up for any questions. So if you have any, go ahead and type those in the question or chat section of GoToWebinar, and we will address them right away.
Okay, Nicole, I'm still not seeing any questions, so I'm hoping everything was very clear. And if you, again, if you do have questions after the webinar, you can contact us at the information here. And Nicole, if I'm not mistaken, this will be viewable online at some point after the webinar, correct?
It will. It'll be on our YouTube channel, and we encourage everyone to take a look at the other videos that are up there as well as this one, or you can forward them to your colleagues as well. Okay, I think that that's it. Thank you so much, Steve, for your presentation. And at this time, we're going to conclude our webinar, and everyone can enjoy the rest of their week. Thank you so much.